Hello Year 12, welcome to the first video here for our 17th topic, Locus and the parabola. Okay, now Locus, set of points. Now that set of points, possibly they all have some sort of relationship to each other and they just might, particularly in this unit, they just might together form some sort of curve, like a circle maybe, or even a straight line, or a parabola, very likely. I could describe the relationship between all of those points in the locus. I might describe it geometrically. I might say, the locus is those points that are all 3 units from the origin, right? All of those points that are 3 units from the origin. Okay, we know that to be a circle with a radius of 3. That's a geometric description. Alternatively, I might describe that algebraically and say that is, right, the curve described by the equation x squared plus y squared equals 9. Different ways of describing the same thing. Now, in this topic, we're typically going to be working to move from one to the other, to make a connection between the geometric and the algebraic. We've done this before. Actually, quite some years ago, you started doing this. We call it analytical geometry sometimes, or even coordinate geometry, and that includes things like the distance formula, which you will see on the screen and on your notes. The distance formula is a key to lots of these questions. Now, the distance formula does include a square root, which is not very nice to use algebraically, so we are going to mostly, to make our life a little easier, instead of working with distances, we're going to work with the square of distances. Right? We'll often work with the square of a distance just to make our life a little easier, and you'll see how that happens in a moment. Here in our first example, we're going to use the distance formula to find the equation of a circle with a centre of 5, 2 and a radius of 7 units. Now, we have used in some other units when we've done circles, we could write the equation of that off the top of our head, but right, we're going to use the distance formula to arrive at that. And to begin with, I'm going to want a little diagram. I'm going to introduce some sort of extra piece of information here. Now, please excuse that terrible looking circle. I'm still new to this graphics tablet business. Now, come back here. So there's my center. My center is here at, what did I say it was? 5, 2. And I've got a radius, right, of 7. So I've got 7 units here. And I'm going to say that I've got a point here. I'm going to call it P. Right, point with coordinates xy. Okay, there is a point with coordinates xy that is exactly 7 units from the center, the point 5, 2, the center of a circle. And I want to find essentially an equation that describes all of those points, right? All of those points. What is the relationship between x and y such that, right, such that they are coordinates that are of a point that's 7 units from the center at 5, 2. Okay. Now remember our distance formula. Our distance formula is x2 minus x1 all squared plus y2 minus y1 all squared, and we normally take the square root of that. But I'm going to leave the square root off, and I'm going to say that, let's say, x2, I'm just going to say, that's this one, x minus x1. It's going to be 5. Right, that's x2 minus x1 squared, right? There's my x2, and there's my x1, right? And the same thing with the y's. I'm going to say y minus 2 all squared equals, right, now that has to equal the distance squared, and we know that the distance is 7, so I'm going to call that 49. Now it's going to get a little messy here, and I'm just going to put you on pause so the video doesn't go forever. Right, I'll talk it through. Hang on. No, I don't know what I'm talking about. That is perfectly fine there. There is the equation of a circle, x minus 5 all squared plus y minus 2 all squared equals 49. Okay, we've used the distance formula of sorts to arrive there. Now, while that seems like a bit of a facile question, something that you're not likely to be asked, it is important to help us understand example 2, which is becoming a bit more complex as we go along. Now, the equation of the locus of a point that moves so its distance from the point A to 1 is twice the distance from the point B, -4, -5. Geez, what does that look like? I've got 2 points and another point that is always closer to 1 than the other, right? Always closer by a fixed ratio. Okay, so consider this. We're going to have a point P, X, Y again. And the distance, right? Oh, hang on, I need to get to my drawing thing. Right, I'm going to say I've got a point, X, Y, and the distance from A to P is equal to twice the distance from B to P. Now, I should probably put these things here to indicate that we're talking about the length of that interval, AP and BP. Okay, so if that's the case, well, my point has gone crazy again. If that's the case, then the length of AP squared, remember that makes our life easier. Right, now we're going to square the left-hand side, we're going to square the right-hand side, which gives me 4 times BP squared. Rightio, I've got that. So, why is that helpful? Well, AP, just like we did in that previous question with the circle, right, the length of AP squared is equal to x minus 2 all squared, right? X minus, come over here, pointer. There's the 2 that we're talking about. X minus 2 all squared plus, right, y minus 1 squared. Okay, so that is equal to 4 lots of, now we'll do the same thing over here. I'm going to call it, oops, I need another bracket. I'm going to go x plus 4 because of the negative negative. X plus 4 squared plus y plus 5 all squared. Okay, rightio. Now we're going to expand those out and collect like terms. I'm going to press pause just to shorten the video. Here we are with magic video. So we've expanded those out. Right, using our perfect squares, we should be efficient doing that now. And then I've collected like terms, and seeing there's a common factor of 3, I've taken that out, and because I've got a 0 on the other side, really, I can just actually, well, come here, I can just eliminate that 3. We won't need that at all anymore when we work through this. So now the net, because we've divided both sides by 3, 0 divided by 3, perfectly fine. Not much happens though. So how do I get from here to something a bit more meaningful? Well, from here I am going to have to complete the square. Remember how to do this. So it's x, and then I halve this, plus 6, all squared. Now I'm going to do it minus 36, plus y plus 4, oh sorry, 7, all squared, minus 49. I've still got the plus 53 here, equals 0. Now this gives us x plus 6 all squared plus y plus 7 all squared. And what do we have here? I'm going to put 4 of those. I think that equals, does that equal 32? No, 4 of those equals 32. Oh, I don't love that very much. Okay, so this is circle, oops, center, -6, -7, radius, it's the square root of 32. We could say it's root 32, but we should say that it is 4 root 2, I think, is the radius. There we go. That's it for the first of these videos. Under 10 minutes, as long as I cut it up soon. Remember, we're going to use the distance formula, right, given some sort of a description. We're going to be given a description, typically, and then we're going to use the distance formula, probably the square of the distance formula, and plot our way through until we arrive at something that is recognizable. Okay, if you've got any questions, and you very well may, jot them down, ask me in class.